Hey there, space explorers! Have you ever wondered what the universe is made of? Well, buckle up, because we're about to dive into one of the coolest ideas in science space-time foam. Imagine the universe as a giant cosmic smoothie. At first glance, it looks smooth and uniform, but if you could zoom in really close, we're talking smaller than atoms here, you'd see something incredible. The fabric of space and time itself gets all bubbly and foamy. It's where the rules of the very big, like galaxies and black holes, meet the rules of the very small, like atoms and particles. And let me tell you, it's a party where anything can happen. Now you might be wondering who came up with this crazy idea. Well, let me introduce you to a rock star of physics, John Wheeler. Back in the 1950s, Wheeler was thinking about how the universe works at its tiniest scales. He knew about Einstein's ideas of space and time being connected. That's the space-time part. But he also knew about quantum mechanics, which describes how things behave at super small sizes. Wheeler realized that at the smallest possible scale, space-time might not be smooth at all. Instead, it could be constantly bubbling and changing, like foam on a stormy sea. This was a huge deal. It meant that the very fabric of our universe might be way more complex and dynamic than we ever imagined. Okay, so what exactly is this space-time foam? Let's break it down with some fun comparisons. You know how a smooth beach looks all flat and perfect from far away? But when you get up close, you see all the little grains of sand? Space-time is kind of like that. From our everyday perspective, space seems smooth and continuous. But if we could zoom in to incredibly tiny scales, we're talking way smaller than atoms. Things might look very different. Imagine space-time as a giant bubble bath. At our normal size, we just see the surface of the water. But at the quantum scale, it's all foam. Tiny bubbles are constantly forming and popping. These bubbles represent fluctuations in the very structure of space and time. They're popping in and out of existence faster than you can blink. And they're so small that they make atoms look like giant beach balls in comparison. Section 4. Quantum meets Einstein. All right, space cadets, it's time to put on our thinking caps. We're going to see how space-time foam fits into the bigger picture of physics. On one side, we have Einstein's theory of general relativity. This is all about how gravity works and how it shapes the universe. Einstein showed us that space and time are connected, like a cosmic fabric that can bend and stretch. On the other side, we have quantum mechanics. This is the rulebook for how things behave at super tiny scales. Space-time foam might be the peace treaty. It's a way of thinking about the universe that combines the big, relativity, with the small, quantum. Section 5. Foam in the cosmic kitchen. Let's take a trip back in time, way back, to the very beginning of the universe. Scientists think that in those first moments after the Big Bang, everything was incredibly hot and dense. Some researchers believe that the early universe was a seething mass of space-time foam. Imagine a pot of water just starting to boil. That's what the fabric of reality might have looked like. As the universe expanded and cooled, this foam settled down into the smoother space-time we see today. Scientists are working on super-sensitive experiments to look for tiny wobbles in light from distant stars. These wobbles could be caused by the light passing through regions of space-time foam. Section 6. Embracing the cosmic mystery. All right, young scientists, we've been on quite a journey through the foamy fabric of the universe. Understanding space-time foam is like peeking behind the curtain of reality. It reminds us that the universe is far stranger and more wonderful than we can imagine. Every time we learn something new about the cosmos, it opens up a whole new set of questions to explore. The mysteries of space-time foam are still waiting to be solved. Maybe you'll be the scientist who figures out how to detect it, or who uses it to invent amazing new technologies. The universe is full of wonders, from the largest galaxies to the tiniest bubbles in space-time foam.